Hi there. You might be wondering what I'm doing. I'm playing a game. We're going to see if I can start at one point, hit all the other dots exactly once, and finish where I started. Think I can do it? The good news is, if you make a mistake, you can always go back and redo it. And just don't hit a point that you've already hit. I think I'm doing okay right now. Whoops, I think I'm going to undo that. Life is full of opportunities where we make mistakes, and those mistakes are something we can definitely learn from. Hey, I did it. Hi, everybody. This is Mr. Molikash. I'm one of the math teachers at South Garner High School. Teach Math 4 Honors and Math 4 and Pre-Calculus, and a new course to North Carolina called Discrete Mathematics for Computer Science. And that's the class I want to talk to you about today. Discrete math is a very interesting class. It's a lot of fun to learn about some of the topics. So I'm just going to take you through a journey of some discrete math things and tell you a little bit about the class in hopes that you'll sign up for this next year if you're interested. Discrete math for computer science, it has computer science in the name now, where it didn't up until this past year. And you'll find out that discrete mathematics is very important in computer science. So one of the problems that discrete math helps us solve is this thing called the traveling salesman problem. And the traveling salesman problem basically says, given a list of cities and distances between each pair of cities, what is the shortest possible route that visits each city exactly once and returns to the origin city? And if you're paying attention at the beginning of the video, that's exactly what I was doing in my game. But it doesn't have to be on that particular graph. It can be any network of cities. And this is a big problem that computer science can definitely solve. There's some practical problems that discrete math can help us solve. For example, in how many ways can 3 men and 3 women be seated in a row with no seating restrictions? And the answer is 120. So if it doesn't matter if women or men are sitting alternately or one right behind the other, we can do 120 different seating arrangements of those 6 people. And it's pretty simple to figure that out using discrete math, but to list all of them would be a chore for sure. And what happens if the men and women must alternate in a row? Well, that's a different story then. So we can solve problems like this pretty easily with just simple multiplication. Another problem that we can look at from the discrete math arena is one like this, where Dr. and Mrs. Smith recently attended a party in which there were 5 other couples. Maybe there was some classical music at the party. Various handshakes take place. No one shook hands with his or her spouse. No one shook his or her own hand. After all the handshaking was finished, Mrs. Smith asked each person, including her husband, how many hands he or she had shaken. To her surprise, each person gave her a different answer. How many hands did Dr. Smith shake? You might be surprised to know that the answer is only 5. 5 hands. If you want to know exactly how it's figured out, I'll leave the link in the description. Earlier, we were looking at this game. It's called the Hamiltonian Game. It was developed by a man named Hamilton, not Alexander Hamilton, this William Rowan Hamilton. He invented this puzzle and sold it, marketed it, and his goal was to see if one can start at one of the points on this network and visit each point exactly once and return to the origin. So this is essentially like the traveling salesman problem. It's pretty interesting. I'll link this in the description as well so you can play the game. And we can build these games. We'll get to do that kind of thing hands-on in class. So it's modeled after this thing called an icosahedron, which is a really fancy way of saying 20 triangles all glued together. And believe it or not, if you connect all the centers of 5 of these triangles, you get a pentagon. So you can put something inside this called a dodecagon, which is made up of pentagons. And certainly this game is made up of pentagons. So there's a lot in common between geometry and discrete math. Another thing that we can talk about in discrete math are some logic puzzles. For example, let's say Ben works at Nemo Sushi and he needs to figure out the total bill for a number of different customers, each of whom ordered 2 different types of sushi rolls. Using only the clues below, match each order to its price and determine the name of each customer. And we can look at the clues and we can create a grid. And these are logic puzzles that maybe you've played before that can be figured out using discrete math. Speaking of logic, maybe you've played this game called Sudoku. Sudoku is a discrete math problem. It has a certain number of digits, 1 through 9, that have to fill each square, each row, each column. And these puzzles are really fun for a lot of folks. Sometimes they're aggravating. It just kind of depends on who you are. I have a love-hate relationship with Sudoku, but it's definitely a discrete math problem. So you might be wondering, what is discrete math exactly? Discrete math for computer science is an honors class that it's recommended that you take honors math 4 or pre-calculus before taking it. So it's an upper level math class that would be taken mostly by seniors as they're taking their last math class before college. The purpose of the course is to introduce discrete structures that are the backbone of computer science. And basically, discrete math is the study of math structures that are countable or otherwise distinct and separable. So the 9 numbers that go inside of the Sudoku puzzle, or the number of ways to solve a Rubik's Cube, those kinds of things are countable. They can be counted, number of seating arrangements in a classroom. The mathematics of modern computer science is built almost entirely on discrete math, such as logic, combinatorics, proof, and graph theory. At most universities, an undergraduate level in discrete math is required for students who plan to pursue careers as computer programmers, software engineers, data scientists, security analysts, and financial analysts. Students will be prepared for college-level algebra, statistics, and discrete math courses. And if you're interested in taking Mr. Guthrie's AP Computer Science course, this would be a huge advantage to you if you're interested in computer science as a career. I'll link this link here in the description as well. So speaking of computer science is actually very useful in mathematics. In fact, there's this thing called the 4-color theorem you might be familiar with. It says basically any map, any plane region that's split up into subregions can be colored in 4 colors where no 2 colors touch each other. Isn't that amazing? So believe it or not, this was one of the first things that was proved to be true by a computer, by something called brute force. So they looked at every single possible map that could ever be made and used a computer to look at every single one of them. And it turns out that the computer could do every one of them with 4 colors. So for example, the United States map, it only takes 4 colors to color it, and no 2 colors are touching each other. There are no two reds touching each other. There are no two blues, no two greens, and no two beige colors. Amazing. So one of the challenges will be, I'll give you a map of maybe Europe or some other region, maybe the county map of North Carolina, which has 100 counties, and see if you can color it using 4 colors where no two colors touch each other. One of the really important applications is the COVID-19 map. This is a partial map of North Carolina, and you can see how the map is colored based on the number of cases in COVID-19 in each area. See, I think Wake County is about right here, Wake and Johnston, and then there are some surrounding counties that have, lesser populations and therefore less cases of COVID-19. But computer science and discrete math is exactly what is driving this map, using data analysis to create these colors. And giving the instructions to the computer or to Google to do this is exactly a discrete math problem. So let's see, we're almost done here. The last thing I want to tell you about is if you have any questions about discrete math, if you're interested at all, I'd like to send me an email about those questions. I'll be happy to talk with you more about the class. My email is jmolokkac@wcpss.net. Thanks for watching. Hope you have a great day, and I look forward to seeing you in discrete math next year.